Today we'll be talking more about segments and introducing some vocabulary. First, we'll talk about the midpoint. The midpoint, M, make a little point here for M, is the midpoint of segment AB. Then AM, this part, and MB, this part, are what we call congruent. And that means that they have the same length and the same shape. And I'm going to make that symbol just a little bigger here. So the equal sign right here means that they have the same length, and the little squiggly on top of it means that they have the same shape. So the M is right in the middle, and this would be kind of an example would be if you had a chocolate bar and you were going to split it evenly with a friend. You would try to split it at the midpoint or down the middle. Now, a segment bisector, it is a point, a segment, a line, or a plane that divides a line segment into two equal parts. So you can think of a segment bisector as being a midpoint, but it doesn't have to be a midpoint. It could be something else. Like in this picture, I'm going to grab a highlighter. This is the bisector, and F is the midpoint. The bisector is cutting through at the midpoint, which is F. So just some examples. G is the midpoint of FH. We're going to make some congruent marks. One mark here, one mark here. That means that those two parts are congruent. So 12 equals X. This piece is 12 inches, and this piece is 12 inches. In the second example, PR is the bisector, and S is the midpoint. So that means that the two pieces are the same length. This piece and this piece, 13 equals X. I'm going to pause the video, let you try just a couple. These are very similar. The one thing you might want to do, because it's asking you to find SU, is label this part X. Okay, so we know that if G is the midpoint, then this piece is 19, and this piece is also 19. So now we're back to the information that we used from yesterday, where we have a part plus a part equaling a whole. It just so happens that here, these parts are exactly the same size. In the second example, they want us to find PQ, and they're telling us that RT right here is bisecting PS. That means that Q is the midpoint. So that means that right here and this part right here are the same, and X equals 9. Here's some harder examples. They're not harder because the vocabulary has changed. They're just harder because the algebra to solve the equation has gotten harder. This is an opportunity for you to use Desmos for these harder examples. So in the first example, it says that EG bisects DF. So that means X plus 4 and 2X minus 8 are the same. And we can plug that right into the Desmos calculator and get X is 12. Here, O is the midpoint of NP. So we know that this piece, X plus 4, and this piece, 2X minus 6, are the same, so we set them equal. Here's where you can plug it right into the Desmos calculator and get x equals 10. I'm going to pause the video, ask you to take a try here. They would like you to find the length of EG. This may or may not be a midpoint problem, so please read. Here I see that EF is a part and FG is a part, and they're asking me to find EG, which is the whole. And nowhere in here did it talk about anything being a midpoint or a bisector. So this is going back to what we learned yesterday with 2 is a part, 6 is a part, X is the whole, EG is 8. Let's try another. Here we don't have a picture. These are just points A, B, and C are collinear. Point B is between A and C. And we're going to find the length indicated. And a little clue here, you have to solve for X first. So let's draw a picture. Point B is between A and C. We know that AB is 16. We know that BC is 12. So those are our 2 parts. And we want to know what AC is the whole. So this feels like yesterday. This doesn't say anything about midpoints. So 16 is a part. 12 is a part. AC is our whole, which is 28. Doing the same thing over here. Going to draw a very similar picture. Remember, B is between A and C. If AB is 13 and BC is 9, then what is our whole? We can just add those up. Not too hard. Now here they don't mention anything about midpoints, so we can use our part plus part equals whole. Go ahead, take a moment, try to solve these, and we'll come back and go through them. So if I do part plus part equals whole, and make that part X, that part 20, and that whole 32, I could either solve this by hand or put it into the Desmos calculator and get X is 12. And here, I would make that my X. And X is 16. Now here's one for you to try, where M is the midpoint. And it says that PM is 7x plus 8, and MQ is 5x plus 20. And draw the diagram. So let's draw the diagram together. So we have segment PQ, and we have M as the mid. So I'm going to try to put that right in between there. Now, it says that PM is 7x plus 8, and MQX plus 20. And remember, M is the midpoint. So these 2 pieces are the same length. So they're equal. We set them equal. We don't have a whole here. So when we solve, we'll get X is 6. Now if we want to know what PM is, we'll substitute 6 for X, which will be 42 plus 8, which is 50. Here for MQ, we're going to substitute 6 for X, which is 30 plus 20, which is also 50. And that is an excellent way of checking ourselves. So if this piece is 50 and this piece is 50, how big is the whole piece? Well, it's part plus part equals whole, or 50 plus 50. You try one, but first I'll help you with the diagram. B is the midpoint of A, C. And we'll pause the video. It's very much like the last problem, friends. So try setting it up and solve it. So since B is the midpoint, these two pieces are identical, so we can set them equal. And we'll get X is -3. But in order to figure out what AB is, we have to plug that in, which will be -7. And BC, 3 times X, or -3, is also -7. So the fact that these two are coming out the same means that I set these equal to each other and solved correctly. So AC, that's our whole part. That's supposed to be a plus part equals whole.